Hello class. Regarding the differential, we had dy equal to f prime of x dx, and for the multivariable we had total differential, and it is possible to become a w and have partial derivative of x dx, partial derivative of y dy, and partial derivative of z dz. It doesn't matter how many variables do you have. Okay, I'm going to ask you a question. This is the volume 4/3 of pi r cubed. This is the volume of a sphere, a ball bearing, nothing except a ball. And I'm going to come to you, I'm going to say, I need 1,000 of those tiny spherical bearing made with a steel with a radius of 0.01. You said, sir, it is impossible to make 1,000 of them, make it exact like that. You got to give me some error, room to error. You said, your room to error is dr. The change in r is plus minus 0.001. You can go either this above or below. Therefore, you're going to have 0.01 minus 0.001 or 0.01 plus 0.001. Anything beyond these two, to the left or the right, I'm going to throw it away. I'm not going to give you a penny. Okay, I'm a manufacturer. I want to build this. I want to order the material. If I want to order the material, I have to get the upper hand, make sure I don't have shortage in material. Therefore, I'm going to go with the radius of this, and I'm going to say how much my volume changes. Oh, the change in volume. I didn't say derivative. I didn't say rate of change. I said change. That's change. What change? That's the approximation. What is the change? Is differential. What is the differential? Is f prime. But remember, your volume is a function of r. Therefore, you have to take the derivative respect to r times dr. You don't want to say f prime of x dx, because this one you're using r to describe the function. Therefore, your change in this one is 4/3 pi 3r squared times dr. That 3 and 3 is gone. Then what is the change in my volume? Is 4r squared dr. What is the r I ask you to make the radius of my sphere? 0.100 of the inch squared. And what is the change in r you allow me the error? Plus minus 0.001. Therefore, the volume of each of these sphere or that ball bearing is between a number to another number. All you have to do is square that one, multiply by 4. Therefore, 0.01 squared times 0.001 times 4. That become 4, and I need 7 decimal places, and I need a plus minus. But what was the volume of each bearing that I asked you to do it? It was 4/3 of pi. I made a mistake right here. See, I missed that pi right there. I see my number is here. I need that pi. Therefore, I need a pi right here. I'm sorry, I missed that pi. Therefore, I have to take that number and multiply by pi. That number is going to become 1.25 times 10 to the power of -6. Or you can say 1, 2, 3, 4, 5, 6, 2, 5. That's the plus minus change. But what was the volume? The volume was 4/3 times pi times r cubed. Really, the volume is 4.188 times 10 to the power of 6. 1, 2, 3, 4, 5. This is your volume. But this how much error you can make. You put plus minus, so much to the right, so much to the left. That's the change in volume. But the question is here, they said, how much the change in volume is relative to that one? That's called relative change. Relative change is dV over a V. Your V was 4/3 of pi r cubed, but the other one was your differential on the top. The 3 and 3 cancel, it was 4 pi r squared dr. And see, the pi is gone. The 4 and 4 is gone. This one and this one become r. The 3 goes on the top, and that becomes 3 dr over the r. I hope I did my mathematics right. 4/3 of pi r cubed is right. And 3 times 4/3, that becomes 4. That's good. That's good. Okay. See, that's called relative change. And what was dV over a V? It was 3 times 0.001 over 0.01. That was the relative change, the change in volume between the exact and the one you either overestimate or underestimate. You go 2 decimal here, 2 decimal here, and that become 0.3. But somebody said, what is the percentage? The percentage of relative change, you multiply by 100, and that becomes 30%. Therefore, the mistake you make, pretty much it changes the volume by 30%. Then another student gonna say, sir, you call it a sphere. But what happens if I have pi r squared h, and this is the volume of a cone? I said, sir, I'm sorry. I couldn't do this in calculus 1 because this is a multivariable, and I didn't know what to do with multivariable in calculus 1. But in here, I am in multivariable. I can take care of it. By total differential, what is your dV? Is the derivative of v respect to r times dr plus derivative of the v respect to h times dh. Then what is the total changes in the volume when r change and h change? You do it respect to r is 2 pi r h times dr. What is respect to h? Pi r squared dh. Then if I come to you and I said, really I want my r to become 0.1 inch, and I want my height to become 2 inch, but the radius can be changed, the change in radius, plus minus 0.01, but the change in r could become plus minus a half. What is the total change right here? For this r, this h, and this r, you're going to put 0.1 and 2. But for a dh and a dr, you're going to 0.1 and 0.5, and you're going to find the total differential. And what is the relative change? You divided it by the v, divided it by the v. And what is the v? Pi r squared h. And see, the pi and the pi is gone. The r and r become r. The h and the r is 2. That r is gone. dr over the r. But don't forget I have that one. The pi and the pi is gone. The r squared and r squared is gone. Plus dh over the h. This is called the relative change. But somebody said, what is the percentage in change in volume? The percentage is multiplied by 100. Then whatever you found in here, you multiply by 100, that give you the percentage of relative change. Therefore, in engineering, differential has a lots of application. Therefore, you need to study the differential as a single variable and total differential as a multivariable. Thank you.